This is the review video for section 9.5 for the chapter 3 test in trigonometry. And our goal right now is going to be to solve the following equation exactly. We have 3 cosine of theta minus 5 is equal to cosine of theta minus 4. So the first thing we should do is try to get cosine theta by itself on one side. So I'm going to subtract cosine of theta from both sides. That's going to give me 2 cosine of theta minus 5 is equal to negative 4. I'll add 5 to both sides and divide by 2. So I end up with cosine of theta equals 1/2. Okay, so since the cosine of theta is positive, that tells me that I'm either going to have an angle in the first quadrant or the fourth quadrant. And the cosine of theta was 1/2, and so the corresponding reference angle will be pi over 3. And so we'll have pi over 3 here, or pi over 3 here. Okay, so my first possible solution is going to come from the reference angle pi over 3. Now we weren't given an interval for our solutions or a domain for theta, and so we need to just write all possible solutions. So I could have pi over 3, but I could also have any integer multiple of 2 pi added to that to get another solution. Now the other solution here has reference angle pi over 3, but it's in the fourth quadrant, and so that's going to be 5 pi over 3. So we have 5 pi over 3, and again, plus 2 pi k. So that's our full set of solutions to this equation. Okay, now the next one tells us to use a calculator to solve, and we want to round our final solutions to 2 decimal places. Now the danger here is that we should actually get 2 solutions out of this, but the calculator, if we just take the arc cosine of both sides here, the calculator is only going to give us 1 solution. In fact, because what we got out of this was a negative number, that means the arc cosine, when we take that, is going to give us an angle in the second quadrant. Right, the arc cosine always gives you an angle either in the first quadrant or the second quadrant. And if this number, if the cosine of your angle is negative, then the arc cosine is going to give you an angle in the second quadrant. Okay, so when we get the arc cosine of negative 0.6, it's going to be this angle right here. Okay, and we can compute that, and that's going to give us one of our 2 solutions. We have the theta equals the arc cosine of negative 0.6, and that's about 2.21 radians when we put that in our calculator. But we also have the other angle where the cosine of theta would be negative, so that's going to be in the third quadrant, right? And it would have the same reference angle. It would have this same reference angle. And so we can actually find this angle because we know that this angle is the arc cosine of negative 0.6, then we know that this angle is as well. So if we take 2 pi minus that angle, we will get this entire angle. So our second possibility is that we have the 2 pi minus that arc cosine of negative 0.6, and that is going to be about 4.07 radians. Okay, so those are our 2 solutions here. Now remember that arc cosine, if we just put that in the calculator, it's only going to give us one of the 2 solutions. And then we need to think about the fact that cosine gave us a negative number, right? And so our original angle theta either had to be in the second or the third quadrant, right? And those are both going to have the same reference angle. And then that allows us to figure out what the angle should be in the third quadrant. Okay, so this next one says to solve the equation exactly. Looks like I have a little typo here. Let me see if I can figure out what I did. so strangely here. I think what I want is that 4 sine squared of theta equal, or minus 2 is equal to 0. Scratch all this stuff. And it was supposed to say that 0 is less than or equal to theta less than 2 pi. So let's edit it like that. I'll write a typo here so I can fix that in my notes. Okay, so this is what we're working with. I'm going to add 2 to both sides and I'll get 4 sine squared theta is equal to 2. And I'm just getting sine squared of theta by itself, so I'll divide by 4 and I'll get 1/2. So now I can take the square root. Since I'm taking the square root of both sides, I need to do plus or minus square root of 1 over 2, which we know can also be written as plus or minus, let's see, that is 1 over the square root of 2, which then if you rationalize, it becomes what we're familiar with, root 2 over 2. Okay, so we actually have 2 equations here. We have the sine of theta equals root 2 over 2, and we have sine of theta equals negative root 2 over 2. So since the sine of theta can be positive or negative, we're going to get one solution in each quadrant, in all 4 quadrants. Right, and we know the reference angle for root 2 over 2 is going to be pi over 4. So we get that same reference angle, pi over 4, for all 4 of those solutions. And so we're going to end up with the 4 solutions, pi over 4, which is in the first quadrant, and then we'll get the second quadrant solution, which is 3 pi over 4. The third quadrant solution will be 5 pi over 4. And finally, in the fourth quadrant, we'll get 7 pi over 4. Since we're restricting our angles to be between 0 and 2 pi, that gives us all 4 possible solutions. Okay, this next one tells us to solve the equation exactly. It doesn't give us an interval, so we'll have to write all possible solutions. And we have alpha plus pi over 4 equals root 3 over 3. So if you want, you can take this alpha plus pi over 4, write it as beta, and then solve the following. You have tangent of beta equals root 3 over 3. Right, and if the tangent is positive, that means that our angle is either going to be in the first or the third quadrant, and root 3 over 3 is going to give us the angle pi thirds as the reference angle. So we have pi thirds there, and we have pi thirds here. And that tells us that we can have beta equals pi thirds, right? And then you can add any integer multiple of 2 pi to that, so you'll get plus 2 pi k. And then when we replace that with alpha, we'll have alpha plus pi over 4 is equal to pi over 3 plus 2 pi k. And when we subtract pi over 4 from both sides, we'll get alpha is equal to, let's see, pi thirds minus pi fourths. That is going to be 4 pi twelfths minus 3 pi twelfths, so that's just 1 pi twelfth. So pi twelfths plus 2 pi k. Okay, so that's our solution coming from our first value for beta, which was pi over 3. Now we'll get a solution coming from our second value for beta, which is going to be 4 pi over 3. So we'll say beta equals 4 pi over 3 plus any integer multiple of 2 pi. So that tells us that alpha plus pi over 4 is equal to that same thing. And now what we're going to do is subtract pi fourths from both sides again. And this time that's going to give us that alpha equals 13 pi twelfths plus 2 pi k. And so now that's our second set of solutions coming from that second possible angle for beta. Okay, let's keep going here. Here's another one that is coming from I guess a quadratic equation. It looks like we can solve this one for cosine squared of theta first, and then we'll take the square root. So I'm going to add cosine squared theta to both sides. So I'll have 4 cosine squared theta plus 4 is equal to 7. Now let's subtract 4 from both sides and divide by 4. And so that's going to give us cosine squared theta equals 3/4, which now we can take the square root. We'll get plus or minus square root of 3/4, which we can write as plus or minus the square root of 3 divided by 2. Okay, so that means we have two equations we're working with here. Cosine of theta equals root 3/2, and cosine of theta equals negative root 3/2. And since cosine of theta can be either positive or negative, we have possible solutions in every quadrant again. And cosine of theta equals root 3/2 when you have the reference angle of pi/6. And so then we're going to have the reference angle of pi/6 everywhere. Okay, so the next thing that we need to do is write out the 4 angles that we get, one in each quadrant. So we'll have theta equals pi/6, 5 pi/6, 7 pi/6, or 11 pi/6. Excuse me. Okay. Now in this next one, we have multiple angles. So that means that we have sine of something other than 1 times theta. Here we have 4 theta. And so what we can do first would be, let's label that 4 theta as alpha or some other variable name. And that tells us we have what? Sine of alpha equals negative root 2/2. Now since the sine is negative for that angle, alpha is going to show up either in the 3rd or the 4th quadrant. And since we had root 2/2, the reference angle is going to be pi/4. So we'll have pi/4 here, we'll have pi/4 here. So that tells us that alpha is equal to, let's see, the first angle here would be 5 pi/4. So alpha is equal to 5 pi/4. The next possibility that alpha could be would be that plus 2 pi, right? And so let's see, what does that give us? 2 pi here is 8 pi/4. So the next possibility would be 13 pi/4. And if I add another 8 to the numerator, I'm going to get 21 pi/4. And if I add another 8, I'll get 29 pi/4, right? And so on. But because my original angle was multiplied by 4, I'm going to need to keep the first 4 angles for alpha. Okay, so we have theta then. 4 theta is equal to each of these, right? And so I'm going to have 5 pi/4, 13 pi/4, 21 pi/4, and 29 pi/4. And now to get theta, I just need to divide each of those by 4. So I'll get 5 pi/16, 13 pi/16, 21 pi/16, and 29 pi/16. And those are my 4 solutions coming from that first angle, 5 pi/4 for alpha. So now what I need to do is get the second angle, which is going to be 7 pi/4 for alpha. So alpha equals 7 pi/4. Okay, the next possibility, if I add 2 pi to that, is going to be 15 pi/4. Right, and then 23 pi/4. And then 31 pi/4. Okay, so when I write this out, I could get 4 theta equals each of those, and then divide by 4 like we did last time, and we're going to get theta equals 7 pi/16, 15 pi/16, 23 pi/16, and 31 pi over 16. And now those are the possible solutions for that. Okay, so we have 8 total solutions in between 0 and 2 pi, and 4 of them came from our first angle for alpha, the other 4 came from our second angle for alpha.